Welcome back, class. Hopefully you're healthy. Hopefully your family's healthy, and you're, staying active, and hopefully you're finding yourself in a time where maybe you just need to, stretch your math legs a little bit, and you want to get some practice with your math facts. Again, I'm providing you another long distance learning opportunity where it's an opportunity. It's not required. I know last week I submitted a couple to you. If you look back in Google Classroom or your email, I sent one out on Monday. I did on my website submit more videos. It's just I didn't send them out via Google Classroom. I thought maybe you'd be inundated with emails throughout the week from other teachers. If you want to go back to my website and try out some of the other videos or activities I submitted throughout the week, you can do that. I just don't want to inundate your email inbox. I think I sent out a couple different, after Monday was the big lesson where I sent out a video in a Google form. On Tuesday, I submitted another website and another opportunity on a website where you could, check try some different, area and perimeter problems out. And then on Thursday last week, I submitted a video where it went over the answers for the Google form that I sent out. I'm going to continue that same format this week. Just, give you an opportunity where you learn from me, you try out a different website that has maybe some different ideas that still are in that same realm of that first activity we did. And then on, end of the week, Thursday or Friday, I'll submit a video where it goes through the answers again. I still want you to try out the Google form, submit them. Again, it's not great, it's not, required. It's just one of those opportunities where you can just continue your education in a different way. But let's jump right in. This is week 2, part 1. If you look back to week 1 on my website, there was 3 other parts I did for week 1. But today we're doing part 1, week 2. Topic today is volume and surface areas. Now we're going to 3-dimensional objects, like a cube or a pyramid of some type. We're going to be using, the different rules and formulas. So I'm going to go through those formulas with you now. If you're going through the Google form later, you'll probably want to have these formulas written down somewhere before you attempt that Google form, because on the Google form I don't have the formulas provided to you, so you'll have to maybe have these written down somewhere. But the figures we're going to go through today, we're going to go through a prism of some type. Prisms can be anything. It could be a cube, a rectangular prism. It could be a triangular prism. It could be anything. But I'm going to focus on rectangular ones for this video. We're going to do a regular pyramid, like a square pyramid, a square base, and then a pyramid going up. A cylinder, like a pop can kind of a thing. A cone, and then the last example I'll do is a sphere, and the sphere is the easiest one out of them all. It's a simple, there's 2 formulas for surface area and volume, and then you just plug in one number, and you just hit enter in your calculator, and it'll just spit out the answer. So those are pretty easy. But the other ones are kind of tricky. You actually have to know the formula, and you kind of have to know where to plug numbers in, and you have to look at the stuff we did last week to even help you out with this week's. So hopefully you went through those. If you didn't, you can always go back. They're there forever. But let's jump right in. Let's start with the first problem. I have about 5 problems picked out here. 4 really, but the 5th one's a sphere, so we don't have to go through too much on that. So this is the formula that we have. This is, in this particular case, I have a rectangular prism picked out. It could be good for a triangle, but what you have to do is you have to find, there's 2 things we're going to have to find. And so when you look at the problems on the Google form, it might ask for surface area versus volume. So if you're doing surface area, that's the top one. So what you have to do is you have to find the perimeter of the base and then take it times the height. And then also add 2 of the area of the bases. That's what all these letters stand for. So the perimeter of the base. So the base in this case on my problem, the one that you're looking at here, the base is this rectangle right here. So the perimeter of that is, it's 10, 10, and 5.2 and 5.2. I'm going to add those up. So I'm going to do that in a calculator, so as you're if you hear me click here, I'm clicking on a calculator. So 5.2 plus 10 plus 5.2 plus 10. And I get 30.4 centimeters. That's the perimeter of the base. Now I'm going to take that times the height of my rectangular prism here. My height is the 6. So I'm taking my 30.4 centimeters and I'm taking it times the 6 centimeters. That's the first part. And I'm going to add this to the 2 times the area of the base. The area of the base. Now the area of the base is it's the area of the rectangle. So how we did that is you just take the length times width. That's how you do it for rectangles. So I'm taking 5.2 centimeters times 10 centimeters. That's the area of the base, because there's 2 of them. There's the top and the bottom. So if I do this, so 5.2 times 10, that's 52, and then I'm going to take that times 2. I get 104 centimeters squared in the back, and I'm going to add that to the 30.4 times 6 in the front, and this is 182.4 centimeters squared. Again, surface area is area, so it's in squares. I'm going to add these two together, and I should get 286.4 centimeter squares. So there is your surface area. Again, now, if you don't like that, maybe that formula didn't make any sense to you, there's another way to do this. So if you think back to class, what we did, we just found the area of each face. So what I mean by that, you just find the area of this little rectangle right here. So that's 6 times 5.2. There's another one over here, 6 times 5.2. That's the two areas of the end caps. The area of the top, I'm going to color this in. The area of the top, that's 10 times 5.2. And then the area of the bottom, 10 times 5.2. That's the area of the top and bottom rectangle. And then you also have the front and back. So the front rectangle is 6 by 10, and the back rectangle back there is 6 by 10. You could add up all 6 of those walls, those faces, that's what they call them, and it would still give you the same number. It would give you this area. Because again, it's just areas of a bunch of rectangles. You could do it that way. Some people like that. They just like to add up the individual areas. But sometimes the formula is just simple. If you know how to use it, if you know what these letters stand for. Again, perimeter, height, and area of the bases. That's what the B stands for. So that's the surface area. So that's one of the questions you're going to be asked to do on the Google form. And again, you can always go back to this video and watch it. I think I have a couple that were rectangles on there. All right, let's now do volume on this particular problem. All right. So volume. So volume is I'm taking the area of the base. So that's what that little B stands for, area of the base. And I'm going to take it times the height. That's what little H stands for. And that gives me the total volume. So that would be in 3-dimensional. So that's maybe, area is like how many little squares fit on the surface, like tiles. But volume is like how many bales of hay could fit in the room itself, or, the actual like liquid you could put in the object. That's what volume stands for, or air in an object. So for mine, I'm going to do the area of the base. The base in my case is that rectangle on the bottom. So I'm doing 5.2 centimeters times 10 centimeters. That's the area of the base. Again, area is the rectangle on the bottom. Now I'm going to take it times the height, 6 centimeters. So I'm going to multiply all 3 of these numbers together. And it doesn't matter the order you do it, but 5.2 times 10 times 6, and I get 312 centimeters cubed. And it's cubic because it's volume. It's in 3 dimensions. That's the total volume of this prism. Again, that's one of the questions they'll ask. Okay. Again, I know that's tough. It's something we did a long time ago. That was, beginning of the year stuff. That was, I think, second unit we did back in September-ish. But let's jump right into the next one. Let's do a pyramid now. Pyramid, same thing. It's got some different numbers here. We have perimeter of the base. We have the L, which is the slanted line. You can see here the little dashed line coming to the front. Over here, this is the dashed line going to there. That's the L, and then this is the area of the base. So that's the area of the bottom of this case. That'd be total surface area. So let's kind of walk through these here. Let me get rid of all my markings. Sorry. We'll plug in the numbers here. So. All right, so we're going to do surface area first. So half the perimeter of the bottom. So in my case, this is a square pyramid. So mine, the perimeter is 6 by 6 by 6 by 6. I made this problem in such a way that all the areas were the same as square. It's irregular. So that's 6 times 4, that's what, 24 centimeters? That's the perimeter of the bottom. And when you add up all those 6's together, add those all up. All right, and now we're going to take that times the L, which is the slant line. In my case, that's the line going down, so that's the 5 centimeters. That's my little slant line. And then we're going to add this to the area of the base. So the area of the bottom is 6 times 6. It is a rectangle on the bottom, so you multiply those two together. So this ends up being 36 centimeters squared. That's the area of the bottom. And then the front, that's half the 24 times 5. And I'll multiply those two together before I cut it in half. But again, if you take 24 times 5, get 120, and then you cut it in half, you should get 60 centimeters squared, and then you should be able to add that 60 plus the 36. And this ends up being 96 centimeters squared. That's the total surface area of this object. Now, if you don't like that, basically what it's doing is it's finding the area of the triangle, but it's adding them all up, and then it's adding the area of the base as well. That's what it's actually doing. It just happens to be regular, so every face is all the same. That's why they're doing it that way. All right. Hopefully that made sense. It's one of those things that you just kind of need to see it. That's the area of the total there. All right. Let's go to the next one. So let's go to volume. All right. So volume. Area of the base. Ooh, that's 1/3. Take the area of the base. So in my case, area of the base, that's a rectangle. And then you take it times how tall it is, the height. Now the height is not the slanted line. The height is the line in the middle of the pyramid, from like the middle of the floor straight up to the peak. That's height. So the area of the base, in my case, the base is 6 by 6. It's a rectangle on the bottom, or a square. So it's 6 times 6. And then we're going to take it times the height, which in my case, this is 4 centimeters. And we're going to get all that number, and we're going to divide it by 3, or multiply it by 1/3. So this ends up being 6 times 6 is 36 centimeters squared. We're going to take that times 4 centimeters, and then divide this by 3. 36 times 4, let's see, it's 144 cubic centimeters, and then I'm going to take that times 1/3. And if I do this correctly, I think it ends up being like 48 cubic centimeters. That's the total volume in this case. Let me double check that in the calculator. 144 divided by 3, 48. Yep. Again, that's the total volume, the air or the water that can fit in that object. Again, it's just knowing where those numbers are and what number means, like what each letter means. So again, if you're going to that Google form you're going to do later, it'd be a smart idea if you write these formulas down off to the side. All right, let's go to the next problem. We have a cone here. So cone, you have a radius of the circle on the top, you have the slant line, which is L, and then the height, which is from the middle of the cone directly down to the point at the bottom. So the formula for surface area, here it is. So we're taking pi times the radius. In my case, the radius of this would be 15 inches. That's the that's the radius of my cone. That's from here to here. And then we're going to take that times the slant line, which in my case, the slant line is 17 inches. And we're going to add this to pi times my radius squared. So my radius is 15 inches, and we're going to square it. And that should give me my total. So 15 squared, 15 times 15 is 225 inches squared. We're going to take that times pi. And then add this to, for some reason I can't put an addition sign. There we go. 15 times 17, I don't know off the top of my head. 15 times 17 is 255 inches squared times pi. That's 255 pi plus 225 pi. These are in inches squared. And so this ends up being 480? 480 pies, inches. 225 plus 255. It's 480. And if you actually multiply 480 times pi, I calculate pi is 3.14, but this ends up being 1507.96 inches squared. That's the total surface area, how many little square tiles would fit on the surface of this cone. All right, so that's the surface area. Again, it was pi times the radius times the slant line, and then pi times the radius squared. So that's that top one. Now let's do the volume of this cone. All right, so volume of the cone now. Let's get rid of all my marks here. All right, so volume of this cone, it's 1/3 times pi times my radius squared. So my radius was 15 inches, and we have to square that. And then we have to take that times the height. Well, the height of my pyramid happens to be 8 inches. That's the height going from the middle up. All right, so 15 squared, that's the 225 again. 225 inches squared. We have to take that times 8 inches. And then we have to take it times pi, and then take it times 1/3, or divide by 3, however you want to think that. But 225 times 8, that is a 40. Carry a 1, that's 16 times 4, that's a 20. And then, I can't do that in my head. What is that? 225 times 8. 1,800 inches cubed times pi, and then times 1/3. 1/3 of 1,800. What is that, like 600 or something like that? 1,800 divided by 3. Yeah, 600 pi inches cubed. And if you actually take 600 times pi, or 3.14, you get 1884.955 inches cubed. And that's the total volume. That's how many little bales could fit in that object, or scoops of ice cream, if you will. All right. So that's a cone. Again, that's the volume of the cone. Again, these formulas you just have to kind of have written down and kind of know what each part is. All right, let's go to the next one. We have a cylinder now. This is second to last problem here. We'll do surface area first, and then we'll kind of jump right in. All right, so surface area. So we got a big formula here for surface area. We take 2 times pi times the radius, and the radius of mine is 6 feet, times the height of my cylinder. The height of my cylinder is the 18 feet. My cylinder's turned on its side. There's the first part. Then we have to add 2 times pi times my radius squared. My radius is 6 feet, and we have to square that. So 6 squared is 36 feet squared. We have to take that times pi times 2. That's 72 pi. That's 36 times 2 feet squared. And we're going to add that to the 18 times 6 times 2. That's what? 12 times 18? That's 18 times 6 times 2. That's 12 times 18, which is 216 pi feet squared. And I should be able to add these two together. 216 plus 72, that's 288 pi inches squared. And again, if you take 288 times pi, that's 904.77 inches squared. That's the total surface area. It's how many little square tiles can fit on the surface of that can. Again, just following the formula here that I used. Hopefully you can see where the numbers are coming from. Kind of going quickly as I go through these. All right, and the last one here. Let's do volume now. Whoa. Let's do the volume. Okay, volume. Pi times my radius squared, so 6 feet. Whoa. There we go. 6 feet squared. Okay, for some reason I can't write in the middle of my... Okay, let's just start over. Pi times 6 feet squared. Would not allow me to write that earlier. And then we take it times height, which is 18 feet. Okay, 6 feet squared, that is 36 feet squared. Feet, geez, not allowing me to write that, times 18 feet. And then we take that times pi, and this will be the volume. So let's see, 36 times 18, what is that? That's a big number. 648 pi. That's feet cubed, because that's what volume is. It's always in 3 dimensions. And then 648 times pi, 2,035.75 feet cubed. It's the number of bales that could fit in there, liquid, if you will. That would be in that little pop can. And that's the volume of it. Again, the formula is pi times the radius squared times height. All right, let's go to my last slide here. The last problem was a sphere. Now, I didn't have any problem picked out here from before, because again, you only need one number Now that seems weird. You only need one number for sphere. You just need radius. So if you have radius, so let's say you have your actual like three-dimensional object and the radius from the center to the outside. Let's say that was 4 inches. If that was your radius for this ball of some type, you just plug that number in here and here, and you get both numbers. So if I want to do surface area, it's 4 times pi times my radius, which ends up being 4 inches squared. So 4 squared is 16 inches squared. I take that times pi and then times 4. And 16 times 4 is 64 pi inches squared. And 64 times pi, you can figure that out. That's surface area. And then volume, I'll switch up the color here. Volume is just the same thing, 4/3 pi, and then you just take your radius. In my case, my radius is 4 inches, and I cube that. So 4 times itself 3 times is 64 inches cubed times pi times 4/3. Now how you do this part, I'll actually do this part for you. I'm going to take 64 times the 4 and then divide by 3. So 64 times 4 and then divide by the 3 on the bottom. So this ends up being 85.3 repeating pi inches cubed. I took 64 times 4 and then divided by 3. It was going to be a nasty number. And then I take it times pi. So this ends up being 268.08 inches cubed. There's surface area and volume for a sphere. The reason why I didn't have a problem picked out is because you only need radius. If you have diameter, cut it in half. You have your radius, and then you just plug into the two formulas. Again, I'm going to submit a Google form out to you. You can go through that Google form on your own. I'll submit answers out later this week. I'll kind of check what your answers are, because I do check through that Google form to see who's kind of doing it and what their answers you're getting. And then at the end of the week, I'll go through all the answers. You can check back and see how you did. Hopefully you're staying healthy. Hopefully your family's healthy. Take care of yourself, and I will hopefully see you later. Goodbye.